All right, they gave me the thumbs up. Okay, that means I can go. All right. Let me get started so I don't continue to push the time. All right. Thank you very much for the introduction, Kathleen. For those of you who don't know me, I'm Matthew Fredrickson, and I work at Digium, and I'm here to represent the Asterisk project and talk a little bit about it and what's going on with it this year. All right, so for those of you that haven't worked with me before or haven't met me before, I've worked at Digium since about 2001, so I've been involved with the VoIP industry since about 2001 or so. And I got a job there a very long time ago. Mark Spencer asked me if I wanted to have the opportunity to write open source software and get paid for it, which at the time was kind of a special thing. That didn't happen very often. It's a lot more common now, but back then that was a very unique opportunity. I was really excited to do that. And so over the years, I've got to be able to work on the Asterisk project in different capacities, in different ways, directly and indirectly. Sometimes at a more core team level, and other times taking Asterisk and adapting and modifying it to use and build new Digium products. I was the maintainer of Asterisk ISDN stack, libpri, and the DAHDI project, which is the set of hardware drivers that are used to drive a lot of the telephony cards that Digium sells. And so I got the opportunity to help in maintenance and taking care of those drivers. I wrote a number of them, and also got to help in the design of some of our hardware products and things like that. At that time, sometime around that time, I realized that Asterisk didn't have a good open source SS7 solution. And so I wrote an SS7 stack for Asterisk that's used in lots of places in Europe and all over the world and things like that to help Asterisk connect with some of the old dinosaur switches of the industry. And actually, it's still used in a lot of areas. And a little bit after that, I got asked to work on some WebRTC related initiatives at Digium. Digium had realized that with the new WebRTC related technology that was coming to browsers, that there was kind of a gap to fill as far as sort of supplementary technologies that need to be developed to build better WebRTC solutions. And so I got involved at that point with some backend web development initiatives and things like that. And actually that's how I'd really come to know Dan Jenkins. Is I'd worked with him a bit on that project for a few years, and it was a lot of fun working with him. He was a brilliant individual, and I figured if he was going to throw a conference, that he was going to do a great job at it. So I wanted to make sure I was there. A few years ago, they asked me to take over as the lead of the Asterisk open source project at Digium. Matt Jordan, my predecessor, who filled this capacity before me, they moved into more of a CTO role in the company to provide more oversight across the technologies in general at Digium. And so they needed somebody to fulfill the day-to-day needs of running the Asterisk project at Digium. And so they asked me to do that. And for me, that was a great privilege and honor. And in many ways, it was like an opportunity to come home. And so I was super excited to be able to do that. All right, so I'm going to go into a little bit of history because it's kind of fun to talk about the road we've traveled as we go forward. Asterisk 1.0, raise your hands if you used Asterisk 1.0. Oh man, there are some hands that are raised here. So this is like way back, this is like going to the Wayback Machine right now, right? So actually, as I was like building this slide, I realized that 1.0 is actually, if you look at all the basic capabilities that a lot of people use even now with Asterisk, a lot of those are there, or were already there, right? So it had like ISDN support, it had, analog support. So all those technologies were, they're still kind of relevant now, but they were very, very relevant back then, right? It had H.323 support, it had MGCP support. How many of you used MGCP before? All right, not so many hands. Okay, yeah, I love MGCP, but it is definitely not taking the market like SIP has, right? AGI support. Did any of you use the AGI interface or have used the AGI? So a lot more hands up. Yeah, so that's a really popular interface with Asterisk, right? And I remember when Mark had the idea for it, and he was like, "Wouldn't it be really cool if we had something like CGI, except it was for telephony, for controlling Asterisk?" And that's how the AGI interface was born. We thought it was really neat. I don't think any of us realized how much it would take off. The SIP channel driver existed, so we had our first SIP channel driver there. There were a number of releases that came later, and some of those releases, some of you still run and still really enjoy. But we're going to jump forward to Asterisk 1.6. That was where we debuted wideband audio support into Asterisk. So we broke the 8 kilohertz barrier. So the traditional narrowband telephony experience, we decided it was time to get past that and to spread things out for newer interfaces as far as like supporting better quality audio and things like that. Since I wrote the SS7 stack, I had to shamelessly plug the SS7 support that went into Asterisk 1.6. That was really important to me. It was really neat to see. So we had some more time pass, and a lot more versions, major versions, and we eventually get around to Asterisk 11, which is something that was a really big release. It had the beginnings of WebRTC support in ChanSIP. So that's a technology that's increasingly becoming more and more relevant these days. Asterisk 12 debuted our new SIP channel driver. For those of you who are not familiar with the history, I think as developers determined that the original SIP channel driver, while it was great and did a lot of very good things for very many people, it had gotten to the point where it was difficult to maintain. And to the point where we realized that it was difficult to salvage the code as was, or as is. And so we decided that it would be prudent to sort of start again from the ground up in terms of SIP support and building a SIP stack, and in a way with an architecture that was friendly to developers and how you work with it and fixing bugs. And I guess to further clarify, we got to the point with the original SIP channel driver where oftentimes you'd fix one bug, you'd create 2 others or something like that, because it was built in such a way that was not friendly to clean interfaces and an architecture that allowed us to be able to do things like that. And so that's another reason why we decided to write a new SIP channel driver. And that was called ChanPJ SIP. We also debuted a new interface for Asterisk called the ARI, or the Asterisk REST interface. So this is, for those of you who work in the web world, this is a way for you to RESTfully control Asterisk, to be able to build calls and build bridges and things like that, and programmatically be able to do that via a REST-like API. And and that's becoming very, very relevant for the current web developers and things like that, to be able to connect better with that market. Asterisk 13 was more of an iterative major release, included more ARI support, more PJ-SIP support, lots of stability enhancements and things like that. Asterisk 14 had some asynchronous DNS support added to its core. So operations that previously would have blocked due to slow DNS operations, now they don't have to do that. There's more ARI support, and I say more ARI support because there's always more things that you can do to better control Asterisk. So that's a frontier that can always expand. And then there was the ability to be able to publish presence-related information to an external SIP proxy like Kamailio, and to be able to do it in a standards-compliant way. So Asterisk 15, Asterisk 15 came out in October of last year, and I want to focus a little bit more on what happened in Asterisk 15. Asterisk 15, we decided to start pushing for better and improved video support in Asterisk. Asterisk actually has supported video for a very long time, but with some of the newer WebRTC related technologies, we realized that we wanted to support Asterisk 15 in a way that was more appropriate for those environments. You had these really awesome browser-based endpoints that supported decoding multiple video streams, and you could render multiple video streams at the same time and do some really cool things that really otherwise you'd have had to have an expensive proprietary client of some sort. Now everybody had access to a client that was really powerful, right? That you could build rich video experiences with. And so we wanted to position Asterisk 15 to be in the market so that it could be a part of those experiences, and you could build these really big, rich, multi-party video experiences with multiple video streams coming out of it. And so what we did is we started looking at some of the technologies we were missing to better interoperate with new browser trends and new browser technologies. One was called Bundle, which is a technology that allows your audio stream, if you have an audio and a video call, it allows the audio stream and the video stream to be able to share a UDP socket. So in traditional telephony, those things are separate, but it was found in the development of the WebRTC standards that the more separate connections that were required to connect between two browsers to make the call code pass, the more separate connections you had, the less likely that you're going to be able to like traverse the NATs involved and things like that. So they decided that they wanted to try to squish everything down to as few ports as possible in terms of the media connections, and bundles the technology that allowed them to do that. Another technology, this is actually just a fancy word for something that's not extremely fancy, but it's called Unified Plan, and that's a technology that's used to represent multiple video streams in SDP. For those of you who aren't familiar with SDP, it is the way in SIP and actually other telephony protocols of exchanging media related attributes and information between two endpoints. So the information necessary to be able to connect a call together between two endpoints from a media perspective. So it contains like, here's my address I want you to send media to. It has things like, here are the codecs that I support, so don't send me any other codecs besides that. All that kind of information that you might need to be able to connect the media part of a call together. And to support some of the multi-stream video stuff, there were some enhancements made to SDP, and those enhancements were called Unified. Well, anyway, it was under a plan called Unified Plan. And so Asterisk supports Unified Plan natively. And you may be asked, okay, so why is that special? Unified Plan, that's kind of interesting, but what's the big deal? Well, there were a number of different proposals for implementing this multi-stream video negotiation support in browser land. Another one was called Plan B, and actually that's the one that Chrome supported for a very long time. But eventually they got to the point where they ratified, as the WebRTC standards, they ratified that Unified Plan was the way they wanted to go forward as far as exchanging that information. And so they went with Unified Plan, and Asterisk decided to support that first instead of going with Plan B first. Like much of the industry. Let's see, there were some RTP layer improvements. So RTP is the protocol that's used to exchange media in traditional SIP land as well as WebRTC land. And one of the things that we discovered was, as we did more and more work with video, that video was very, very sensitive to packet loss. Audio calls and things like that, if there was packet loss or any kind of media level corruption or whatever in the call, audio had a tendency to correct itself very quickly and almost, I won't say unnoticeably, but in some cases unnoticeably, but at the very least with very, very small amount of difficulty. It was just maybe a little blip or something like that for a typical scenario. We found out that with video, if you missed a packet, that suddenly you've got situations where or if the packet-related information was corrupted, like sequence numbers were wrong or corrupted and things like that, you've got situations where instead of it just being a little blip, you've got a body part going across the screen that's not connected to a body anymore, right? Like I'm sure all of you are familiar with that experience when a video decoder gets fried or whatever, and you see like it freezes, or you'll see random pieces of different people moving or whatever, but they're not connected anymore. So anyway, any of you that have had that level of experience, we had that experience as well, and we wanted to find out why. And we figured out that actually there was something that Asterisk had needed to improve upon, and that was preservation of sequence number information across legs of a call, like better preservation of that sequence number information. And we found out if we did a better job at that, instead of having random body parts going across the screen, the browsers and things like that could better detect the situation where there was a packet that was lost, or that it was reordered or something like that. That situation could be better detected, and they can do a better job of correcting that information, and it doesn't look so poor. And so we corrected that in the Asterisk core. We also added support for multiple video streams and multiple audio streams in a call in Asterisk. So arguably, this is one of the largest changes that's happened in Asterisk in the last 15 years or so. But there's a traditional limitation, an assumption, that a call is composed of a single audio stream and a single video stream in Asterisk, and that's existed for a very long time. And it's worked very well for many people in many different scenarios, but in order to move forward with multi-stream video, obviously that limitation needed to be lifted. And so we were at a core level, and inside of Asterisk internal abstractions, we lifted that limitation, and now you can have calls set up with as many video streams or many audio streams as you'd like to set up. And then to cap it all off and connect all these technologies together, we added SFU support to Asterisk, so you could build really cool multi-stream video experiences using Asterisk ConfBridge application. For those of you that use Asterisk for conferencing, things like that, the existing audio conferencing application that you use can also be used to build really cool and rich video, multi-stream video experiences. So you can build a Jitsi Meet or like a Google Hangouts type experience with Asterisk now, which is really cool. And here's like a little picture, or I guess a screenshot of it going down. Now, so this is stipulated. This is backend C developers. When I said, hey, we probably need to build an engineering prototype, this is the way a backend C developer thinks of a web experience. So there's wireframes and there's like funny boxes and things like that. This is not what we bring to the table. We in terms of our talents, most of our talents are in building really cool C code, and that does things really efficiently and powerfully underneath the hood. But most of my team, we're not front-end web developers, so this is not what we have. But if you'll notice, you got like people here, and you've got some boxes, and you can mute the video and mute the audio and things like that. And you can see everybody in the call. These are a couple people on my team. And there's a Lucky Bamboo plant down in the corner. There's a video feed of the bamboo plant. All these these would be live video streams and whatnot. All right, so Asterisk 16, what's next? So there are some things that we discovered in the course of developing Asterisk 15 that we wanted to continue to improve and develop, mostly on the video front, but there are a couple other things that we wanted to hit as well. There were some video quality related improvements that we felt like we wanted to press forward with. There were some WebRTC related API additions that we wanted to attack this year. And then if we got done with all of that, we wanted to try to also look at some potential PJ-SIP channel driver performance improvements. So the first thing I want to talk about with regards to improving video resilience is, as I mentioned before, video is super sensitive to packet loss, right? Packet loss, packet reordering, things like that. It is really, really finicky, and it cares a lot about it. In Asterisk 15, so as I mentioned, we already improved Asterisk's ability to preserve end-to-end sequence numbers with RTP packets and things like that. If we discovered situations where there was packet loss, the way that we handled it from a interoperability perspective is we just indicated that we just requested a new full frame of video to the remote end. And this works reasonably well, but if you want to look at optimal bandwidth situations and things like that, it's kind of the sledgehammer approach, right? It's like, well, I detected that I missed some video frames or whatever, so I'm just going to tell you, retransmit a big, huge, full video frame and reset the decoding context on the browser, and everybody's fine, right? So like I said, works reasonably well, but it is definitely a brute force approach to correcting any kind of loss and things like that. And there are a number of better, more finely tuned approaches for handling that situation as well that we want to support. First one is a technology called NAC. And it is exactly what it sounds like. It's a negative acknowledgement. It's a way to send a proactive or explicit negative acknowledgement to the other side and to indicate that a packet was lost or missing, right? And if you look at the bottom at my little graph, or my little figure down there at the bottom, if you've got an incoming RTP packet sequence and you get 1 come in, 2 come in, 3 came in, and then suddenly you get 6, as a receiver of that stream, you realize, one of these things is not like the other, and I need to figure out what's going on here and realize, okay, 4 and 5 are missing. And so what you can do is you can transmit to whoever sent it to you, can transmit back a NAC that indicates inside of it that 4 and 5 are missing. So the other side can do something proactive about it. It can say, oh, okay, looks like the receiver never received 4 and 5. Let me try to retransmit those RTP packets, which is kind of cool. There are some, while that sounds kind of neat, there are a little bit caveats associated with RTP packet retransmission. It depends on a low round trip time for those packets to be able for this to happen in an effective way. From a practical perspective, we found that for the most part, most video calls, the round trip time is pretty tight, and this technology is adequate for correcting, majority of scenarios that we saw. But as round trip times become longer, it becomes less practical to correct with packet retransmission. And additionally, that has the consequence of increasing the size of packet buffers and things like that on clients and things like that. So there's a couple of impacts that has on clients and that are kind of network dependent as well. There's another technology called REMB, and this is one that's deployed across browsers. It stands for Receiver Estimated Max Bit Rate, and it is an RTCP feedback message as well. And I talked a little bit about, let me get a show of hands. Who's familiar with the technology RTCP? Okay, this is great, actually. So, okay, I was going to figure out how I was going to talk about this and I was going to explain the difference between RTP and RTCP, but it sounds like most everybody's there, right? So RTP is the way of transporting media, and then RTCP is kind of a part of RTP, although it's got a different acronym to stand for it, but it describes things about the audio stream or the video stream that's running. It sends like packet loss information and jitter information, things like that. Additionally, there are fancy ways of doing other things with it. One of them was the NAC request. So the NAC message that I talked about just now is actually an RTCP-based message. And then the next one, the one that I'm talking about right now, REMB, is also an RTCP-based message. It's an indication that happens in the RTCP stream. And so support for REMB support is negotiated in SDP, and it's essentially the receiver's perception of how much video bandwidth or how much bandwidth is used by a particular audio or video stream. So you may think, okay, that seems kind of silly, right? The transmitter should know how much bandwidth is being used by his stream, right? Well, the reason why this is important is if you're in a bandwidth limited connection, let's say the transmitter's on a, I guess to use old world terms, like an E1's worth of bandwidth, like 2 megs, right? And he's like, okay, I got about 2 megs of bandwidth I can saturate and get through. So he sends a 2 meg stream across, but you're on an old, an older connection, maybe 500K limited connection. You're not going to get 2 megs of bandwidth across that 500K connection, right? You're going to get, maybe 500K, right? So you're going to see like you're going to get 1 out of every 4 of those packets or something like that. So it allows the receiver to say, hey, on my video stream that I'm getting, I'm only getting like a 0.5 meg. And you can send that back to that transmitter, and the transmitter can do something intelligent with that. It can say, oh, okay, it looks like there's a scenario where it doesn't matter how hard I try to retransmit packets and things like that. I'm never going to win in this case. Let me just adjust my transmit encoder so that it uses less bandwidth or whatever, down to 500 megs or whatever. And that way I'm not in this situation where I'm continually trying to retransmit packets and I never win because the guy's never going to be able to get that much bandwidth, right? So it's really cool, actually, and it's a great technology that's used to handle these situations better. And without it, you're kind of in this situation where you can never. There's not a great way to detect that condition. And so Asterisk gathers these REMB reports from the different browsers and things like that, and then it intelligently aggregates them together and redistributes them back out so that everybody in a video conference kind of understands everybody else's video bandwidth limitations and can work with it accordingly. All right, let's talk about WebRTC API improvements. So Asterisk 15, we did a whole bunch of work in the core of Asterisk and built this sort of proof of concept SFU using the new changes that we made. But we realized that we'd kind of gotten it together, but there were probably going to be a lot of things that we missed in terms of like building out applications, right? So we built all this really core code that kind of got the media engine working right for building this SFU, but there are probably some additional things that maybe application developers would want to do, and we didn't know those things yet. And so we wanted to budget a little bit of time in this year between the Asterisk 15 and Asterisk 16 cycles to be able to accommodate those things and be able to do some things with it. And so we, if you look at this prototype application that I'd shown earlier, if these are really the letters are really small here, so it's kind of hard to see. But this one right here, this has this gentleman here. His name's Malcolm Davenport, and he's the product manager for the Asterisk project, and he's a really cool guy. But he's wearing his fun hat here, and if you notice that it says the words remote video right here, and then here's our Lucky Bamboo plant, a video feed of that, and it says the words remote video right there, and then here's Kevin Harwell, who's demonstrating right here, and this is his browser, and it says local video on it. So as a user of this conference, you probably already know, your brain knows that picture or that person in that stream is, some guy that I know, right? I know that it's Malcolm Davenport because I work with him, right? But as an application developer, as a web application developer, while the people on the call may or may not know implicitly from the contents of that stream what's going on, there are probably some rich things that you want to be able to indicate in your application. And we realized that there wasn't a great way to correlate from a browser programming interface. There wasn't a great way to correlate this video stream element and the ID that comes with it to like caller ID information in Asterisk or channel information. And as soon as we realized that, we kind of hit our head and realized, oh man, yeah, that's kind of it's hard to build really, next level really cool experiences if you can't do things like that. So we realized that we needed to have some APIs to be able to correlate that information, be able to correlate metadata about those streams and things like that. So that was something that we wanted to try to improve upon, and we've got some APIs in the pipeline that should be coming out Asterisk 16 timeframe to be able to do things like that. So improving performance in ChanPJ-SIP. So there was a great talk at AstroCon last year, and it was talking about performance differences between ChanSIP and ChanPJ-SIP. And in many of the cases, ChanPJ-SIP performed better, which we were super happy about, because that was one of our goals with ChanPJ-SIP, is to build a better, more scalable SIP stack for Asterisk. It's a multi-threaded SIP stack. A lot of the processing in ChanSIP is single-threaded, and so there was a lot of work to multi-thread PJ-SIP. And if you looked at most of the performance tests, a lot of them ChanPJ-SIP performed better. There were, however, a few cases where it did not, which it bothered us a little bit. And so, and this wasn't drastically different. Like, this is on the order of, like, in concurrent call counts for their platform is maybe 1 to 2 calls difference, right? So ChanSIP performed, you got maybe 1 or 2 more concurrent phone calls when doing concurrent call load testing, things like that. And so we wanted to look into some of those scenarios and try to address those as well as part of this cycle. We are getting very close to feature freeze for an Asterisk 16 release. So we've gotten a few things done in regards to this, but I don't know how much more we're going to get before feature freeze. We'll have to see how things go. But we would like to address that. Now, like I said, in most cases, PJ-SIP performed better, in some cases drastically better than ChanSIP, like in the order of, maybe, for call signaling tests and things like that, I think 4 times the performance of ChanSIP and things like that. So there were very many cases where our fruits of trying to multi-thread the SIP stack, there were fruits that came from that. But like I said, we wanted to try to equalize even some of the cases that weren't as drastic in terms of differences. All right, so I'm going to talk just a little bit about the project background of Asterisk. For those of you, who of you all utilize Asterisk in your networks right now? Can I get a show of hands? So there's a pretty good group of people here, right? So I want to talk a little bit about background and policy. So if you look, Asterisk 11 came out in 2012, Asterisk 12 came out in 2013, Asterisk 13 came out a year later in 2014. Asterisk 14, actually we had a big gap between 13 and 14, and it came out 2 years later. And Asterisk 15 came out last year in 2017. If you notice that some of those releases have, in parentheses, an LTS next to them, so who all of you are familiar with the term LTS? Yeah, like probably a lot of you, because that's really important when you're deploying applications. A lot of times you want to know what releases are LTS, and a lot of times as networks and things like that, people gravitate, or as network providers and things like that, people gravitate towards LTS because it means certain things to them, right? So I want to talk a little bit about what this means from an Asterisk developer perspective. So LTS stands for long-term support. And if you notice, Asterisk 11 and Asterisk 13 had those LTS indicators next to it. And in the Asterisk project, what it means is it means that it receives bug fixes for 4 years. So that branch, that long-term supported branch, includes bug fixes for 4 years after it's cut, followed by a year of security-only fixes, or only security fixes. Standard releases for Asterisk, and that includes 12, 14, and actually 15, they only receive bug fixes for 1 year. So the branch doesn't last as long in terms of supported life, followed by a year of security fixes. And if you looked at that pattern before, most of the odd-numbered releases were LTSs. And traditionally, that has been our policy is making those odd-number releases. But with all the core changes that we made in Asterisk 15 with regards to multi-stream video and a lot of the fundamental changes that we made within the core of Asterisk, we decided to make Asterisk 15 a standard release, kind of break convention there and make it a standard release so that we have more time to bake internal APIs and public-facing APIs and not have to support this sort of transition period as those APIs are being baked for a very long period of time. And so we opted to not make Asterisk 15 an LTS release. And so there's kind of a gap there in terms of LTSs and things like that. So Asterisk 16 is going to be the next LTS. There were some people that were a little bit disheartened that Asterisk 15 was not an LTS. And again, we apologize for that, but it was out of an abundance of caution that we decided not to do that. It turns out that Asterisk 15 has been quite an exceptionally stable release, and I think that has owed a lot to the testing infrastructure that we built out. It's been really cool to see as we've continued to build out the test infrastructure for Asterisk. Every major release we've had in terms of major releases has been more stable as a new release than any other previous new release, and that we owe it all to our pretty awesome testing infrastructure, which we've built up over very many years. So Asterisk 16 will be an full LTS and will receive 4 years of bug fixes and an additional year of security fixes. Just as a reminder, Asterisk 11 went end of life in October, so that means that it got past the point where it already had been a year out of receiving bug fixes, and it got past the point where it stopped receiving security fixes. So if you have Asterisk 11 or older installations connected to the open internet, that's probably not a good idea because you're not receiving security fixes. I would urge you that for those of you that run networks and things like that gravitate towards LTSs, I would urge you to, even though this Asterisk 15, for example, may not have been an LTS, it was a standard release, I would urge you to keep on top of what's in those standard releases so you're not surprised when the new LTS comes out, right? So if somebody had accidentally messed up one of your favorite argument to the playback application or something like that, and it's some argument that's very, very, something that you use in your network for a very specific reason or whatever, but maybe not a lot of other people use it, it's a good idea to periodically test and evaluate what's going on in standard releases to make sure that, there are no surprises and things like that for you so that we don't have to have a regression fix in an LTS and things like that. And as part of the stabilization window for a new branch, we've got a few months. So for example, for Asterisk 16, about 2 to 3 months before we make a new release, we cut release candidates and things like that and betas so that you can start evaluating those new big branches and things like that. So I would urge you to try to keep on top of what's going on in some of those newer releases. Let's see, last but not least, for those of you who have not been to Astericon, if you run Asterisk on your network, Astericon is probably one of the best places you can go to figure out what's going on in terms of best practices, figure out what's new with the project and what people are doing with it, and how to better utilize it within your network, see business cases and get new ideas for business. It's a really big conference. There are usually 500, 600 plus people there that come. And it's a very rich conference. It's multi-track, and it's an opportunity to go and really take your knowledge of Asterisk and how you use it to the next level. It's pretty awesome. And obviously that's a shameless plug, but I would encourage you guys to go, and you can see a lot of the familiar names and faces within the community there as well. And if you use the code community 2018, you should receive a 20% discount. And so anyway, I appreciate very much you guys coming and listening to my talk as I talk about something that I love a lot, which is the Asterisk project. I hope you guys have a good day, and if you have any questions, we can talk about them afterwards.